reading these questions well enough. The kids are not reading the questions well enough. So notice when you do a QER, you either copy, tape the question to your QER, because the first blank, this first page, is the question, or you rewrite it or whatever. So I'm going to highlight as I go, because what I highlight I'm going to come back to and talk about. It says the data in the table below gives selected values for velocity. Oh, I don't like pink. All right, so what we're going to do, what are key terms? My first key term is velocity. So what does velocity? What do you know about velocity? It is the first derivative. What else do we know? What else? And is that what we have on this one? Meters per minute. In this case, it's meters per minute. What else do you know about velocity?
The integral acceleration.
Okay, it's the integral of your acceleration. Okay, what else do we know? What does it tell you?
How fast something's going.
Okay, tells you how fast, but it tells you something else. And it tells you direction. What part tells you direction? The sign. That's a C. Direction. Positive, negativeness. All of that. So what we're doing is we're priming the pump. We're getting everything that we know about velocity to the front of our heads. All right, and we already said meters per minute. We included that in our velocity, correct? Of a particle moving along the x-axis. What does that mean? You got to understand the movement. Moving along x-axis. What's that? What? Say that again? It's a right-left movement, correct? That's important to know, because what if there was a maximum or a minimum, right? It's a right-left movement. So that's something you need to know. All right, what else does it say? The velocity v, here's another big term, is a what? Differentiable function. All right, so when you see the word differentiable, you know two things. And I heard one of them. That tells you that the function is continuous and the derivative exists. Now, what does that mean? If the derivative exists, there are no sharp turns, correct? How do we already know there's no asymptotes? Why do we already know that? What's this first word? Continuous. What's the only way a derivative cannot exist and be continuous?
Sharp turn.
Sharp turn. All right, so that's just that part, okay? So now we're going to look at our table. What's the significance of the table? Okay, so when I say table, you have to identify this table. Is this original table? Is this a derivative table? Is this a second derivative table?
Derivative.
Okay, this is a first derivative table. Got to know what you're looking at, all right? It is because of velocity, exactly. Okay, so now, at t equals 0, okay, the particle is the particle moving to the, okay, moving to the right or left. Okay, hold on. So, moving right, left. What will you look at? It's the sign of what? Velocity. All right?
Velocity is derivative.
Sign of the velocity. All right. And why is t equals 0 important? Well, we'll talk about that on the next page. Is there a time during the interval 0 to 12? Now, that is a what?
Interval.
Oh, darn. This is a closed interval. That 0 less than or equal to t less than or equal to 12. What do I want you to think when you see a closed interval? Be BOLO. Be on the lookout for mean value theorem, intermediate value theorem, extreme value theorem. Okay, anytime you see a closed interval, I want you to think of, and now, it might not involve any of these at all.
This one doesn't.
But what we want to do is we want to be on the lookout because these are a lot of times overlooked. Okay, closed interval. When the particle is at rest. Ooh, at rest. Now, what does at rest mean?
That means the 0 is...
Is it at rest? Is it position?
No. Velocity.
It means velocity equals 0.
No.
No? Yes, it does. If you're at rest, you're not moving, right?
Yeah.
Okay.
No, I said no.
Okay. So, do you see how those two little words could be easily overlooked?
No.
Well, no, but is it going to come to you highlighted? No. So these will be underlining on the AP exam. All right. Now it says, ooh, big, 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 big. Use data from the table. All right. So that's what I learned last summer. Use data from the table. What does that mean?
It means use data from the table.
That means you must use numerical numbers from numerical numbers, not alpha numbers. Numerical numbers from table. Okay? In other words, f of 3 doesn't do it. You with me? If you use f of 3 minus f of 1 over 3 minus 2, you will lose the points. Okay. Now, another key word, approximation. What does that mean? Approximation. What does approximation mean? Close to, not exact, right? Okay, it's going to be close to, not exact. Now what did they give you? Oh my gosh, what does that mean? Is that an important piece? What's V prime? V prime of 10 is acceleration. What else could you have thought? Some people didn't think so acceleration. They probably thought what? Second derivative of what? Of position. Or how else could you have thought it? First derivative of velocity. All right, do we know what we need? No. Do we know how to interpret at this point? No. But have we brought that to the front of our minds? Okay, going back up. Explain the meaning of V of t in terms of the motion of the particle. What does in terms of the motion of the particle mean? In terms of motion. What's the motion on this problem? Left and right. What do they want to hear? What words do they want to hear? If you are explaining in terms of motion, moving to the, okay, and then it says show computations that lead to your answer and indicate units. All right, those are important in and of themselves. That means that if you give them just an answer, they will not give you credit, and that means that units, they may, let's say you get a great answer and you don't do units, you've lost the point.
Do just units.
Oh, bald units will not get you the credit either. I learned that last summer. Yes. The kids knew that if all you know is units, then you better put a number with them, whatever number, it doesn't matter, as long as there's a number with it.
Oh, okay.
So if it's supposed to be meters per minute squared, but you have no clue how to get that, and you do meters per minute squared, they will not give you credit. But if there is a point for units, and you have put 10, what did I say? Meters per minute squared, you will get the unit credit.
Wait, even if it's
No, not technically. All right. So now let's read on.
That's how I passed AP.
This is a new one. Oh, now what did they tell you? What did they tell you? A of t, did they tell us what it is? They did. Well, we're going to go ahead and write this down. Now, what is acceleration?
It's the derivative of velocity.
Okay, it is the derivative of velocity. What does it tell you?
The rate of the velocity.
Ah, okay, it tells you how fast the velocity is changing, right? How fast rate velocity is changing. That's usually like in a car, your accelerator, are you slowing, moving, speeding up, slowing down?
Yes.
Having problems there. All right. So are we done? Okay. Is there guaranteed? Oh my goodness. Is there guaranteed? All right. So that should be trigger words. Is there guaranteed? You see is there guaranteed. You see those words? What do I want you to think? I don't think I spelled that right. Okay. I want you to think mean value theorem, intermediate value theorem, extreme value theorem, because what do these three things do? Guarantee something. Okay, they guarantee something. So that's a trigger word. Okay, is there guaranteed to be a time c in the interval such that a of c equals 0? A of c equals 0. What does a of c equals 0 mean?
It's not accelerating.
A of c equals 0.
It's not accelerating. So it's at constant.
No acceleration. So doesn't that mean velocity is constant?
Yes.
Does that make sense?
What is C?
Because you're still moving, right? Your acceleration can be 0, but you can still be moving.
What is C? Is C like all
Oh, that's some number. All right, so this is the part 2. On part 2, what are key terms and explanations? Do you see that? That's a lot. And of course, when you have a free response that has 4 pieces, you're going to have a lot. All right? So I'm only asking you to do one of these per night. And actually, each time I introduce you to a new type of problem, you're going to be doing one. All right, so now, and this is where I need the book. What are the supporting questions and answers? This is where now we are going to start to solve the question. All right? You all are taking notes, correct? You all are taking notes, correct?
My mind.
Oh my goodness. All right. Yes, these are yours to write in. But, however, on the free responses, I did not leave enough space for you to write in. So, all right. So I am on. Here we go. You ready? So now let's start with A. We're just going to start solving now. A. It says, at time 0. Okay, so what's the significance of time equals 0? What does that tell me to do? Look for 0 in table, right? Which column or row? In T row. All right? So is the particle moving to the left or right? So left would indicate negative, and right would indicate positive. So now let's go to the table. Let's look for the 0 in time. What is the velocity? V of 0 equals what? -3. So the particle is moving where? Particle is moving to the left. Now, even though I'm asking you to write one question exploration routine, every time you do a problem, what should you be doing as you're reading?
Marking it. Like,
You should be underlining, highlighting, and you should be going through those questions in your mind. All right? Last year, what I did is I had everybody highlight, and then I called on you at random. and I gave you a free response question, and you had to tell me what you highlighted, and you had to tell me why, and that was a quiz on the spot. This is getting you to do it in a more focused way, and instead of calling on you and telling me what you did on the spot as a quiz, we're going to have it written, okay? It's going to be a written quiz. So every time you do a free response, this is the thought process we go through, whether we write it or not. All right, did I answer that first question? It says, is the particle moving to the left or right? Did I say that?
Yes.
And did I explain?
Yes.
Not really. So the particle is moving to the left because what? Because V of t is negative. All right. V of t is negative. Okay, so let's say you're in an interview for a job, okay? And you'd spell that on the AP exam. Let's say you're in the interview for a job, and they've just asked you a question that literally has 3 parts to it. Do you stop talking and assume you answered all 3 parts, or if you have any question as to whether you answered all 3 parts, what should you do?
Keep going.
You ask, can you please repeat the question? I want to make sure that I answered all the parts. So what I'm trying to explain here is, when you think you have the answer, what do?
Check.
You go back and read and make sure you answered all the parts. Okay, we're on to B now. You ready?
Yeah.
Part B says, is there a time? Is there a time? Is there a time? What are we looking for?
Time.
So you're looking for time, okay? And there was this 0 to t to 12, so that's the bolo. When the particle is at rest. At rest, what did that mean? V of t equals 0. Now, how do we find with V of t equals 0? V of t, now if I do algebra 1 slope, isn't that going to be acceleration? Okay, remember when I said that there's this? What should you be on the lookout for? Intermediate value theorem. Think about it. Look at your table. It is a velocity table. Why is, now listen, velocity table. Why is mean value theorem not an option here? Mean value theorem involves what?
Numbers.
Algebra 1 slope and derivative. Derivative of velocity is what? So if you're doing algebra 1 slope to this table, what are you finding? Acceleration. And what do we need? Velocity. Why is extreme value theorem not an option? It has nothing to do with max and mins. So is there a time? Remember, they told us that it was differentiable, correct? Correct?
Yes.
All right, so how do you look at this table? And I'll go, but look, if you look in the table, there's no 0. Oh, look at this. What do you see here? Negative velocity, positive velocity, differentiable, meaning what? Continuous, therefore what must be true? Okay, so is there a time? We would say yes on 0 t to what was the time? 2. So on the time interval 0 to 2, V of t equals 0, and I would put particles at rest. Okay, particle is at rest. Why? Because V of 0 is less than is less than V of 2. Right? Well, wait a minute. V of 0 is less than V of 2. Let's say, whoa, No. V of 0 is less than 0, which is less than v of 2. So negative 3 is less than 0, which is less than 2. And if you want to make sure they know this, negative 3 is less than 0 is less than 2. Okay? I believe they will accept any of these. Is there a time? Did we say there was a time? Yes. Did we tell them what the time was?
Yes.
There is a time between 0 and 2. When the velocity equals 0, when the particle is at rest. Explain your answer. Have we explained it?
No.
Because of intermediate value theorem. Now, you say IVT, you nailed it. They will accept because v of t is continuous. Okay? It kills me to give credit for this. All right? It kills me to give credit for this because it is what? Intermediate value theorem, which is so much more. But they will give you credit for this. They will not give you credit for saying it's differentiable. Why will they not give you credit for saying it's differentiable?
Because it says it's different.
Because they told you it was differentiable. By saying that it's continuous takes you to a new level. So maybe I shouldn't put a frowny face. I'm just not, ugh.
What happens if you spell out intermediate value theorem and misspell it?
Oh, not a problem.
Okay.
In fact, I would encourage you to spell out intermediate value theorem because there was a college teacher that did not know what IVT was and was marking all the kids wrong.
But I can't spell future.
I don't know. Yeah, they are. So part C. Let's go to C. Now it says use data from the table. Use numbers, okay? To find an approximation. Ooh. Put approximation together with v prime of 10. What does this tell you? What does this mean? Algebra 1 slope. Yes. Because derivative of velocity is what? Acceleration. All right, so let's start there. So what numbers will we use if I want 10? Because 10, it falls in between. So this is what they literally want to see. They want to see 12. The v prime of 10 is approximately equal to 12 minus, just kidding, 5 minus, what was I doing? 5 minus 7 over 12 minus 8. Now, you can leave it this way. You can stop and you get credit. Negative 2 over 4. Why am I going to encourage you to stop? So we don't make mistakes, all right? So the problem said use data from the table to find an approximation for the derivative of velocity at 10. Did I do that?
Yes.
Now, explain the meaning of v of t in terms of the motion of the particle. So I have to explain with respect to motion. What does that mean? Well, what is this telling us? What's happening? What's changing? It's not telling us direction, is it? The velocity of the particle is getting smaller. In other words, the particle is slowing down, right? So now, have I explained the meaning? Have I? With respect to motion. Okay, now it says, show the computations that lead to your answer. Did I do that? And indicate units of measure. Ooh, did I do that? I did not. So I'm going to shift this over and shift that over and shift that over. And what do I put? Meters per minute squared. Do you see why you go back to make sure you answered the question? All right. Last but not least is part D. All right. Part D says, let A of t denote acceleration. All right. A of t, and what are we going to remember? That that's the what? Derivative of velocity. Oh, is there guaranteed? There's the words. What do we do? IVT, MVT, what else? EVT. What does it say after this? Okay, is there guaranteed to be a time? We're looking for t equal to c. In the interval, okay, this 0 to t to 12 just emphasizes is there guaranteed, such that A of c equals 0. Now remember, what is our table? Our table is what? Velocity. So what do you have to do to get to acceleration? Okay, first of all, what is this? Derivative. Okay, derivative. Now, I just heard algebra, because of the table, I heard algebra 1 slope. Now, you put those two together right now. Derivative, algebra 1 slope, which one is it? Why is it mean value theorem? Remember, does the slope of the tangent line equal the slope of the secant line? All right, so what does that mean? We need to find algebra 1 slope. Let's go back to our table. Is there a time when algebra 1 slope is 0? How do you look at the table for this? You've done this before, back first semester. What are you looking for? It's going to be y2 take away y1 over x2 take away x1. In doubt, it needs to be 0 over some number. What is this telling you? In order to get 0 for an answer, what must be true about these y's? And where are they the same? Oh, look at this. That velocity is 5. That velocity is 5. So the question was, how do we finish this? The question asked, is there, let's see, is there guaranteed to be a time c? Is there? First of all, show them that 5 subtract 5 over 12 subtract 6 is equal to 0 over 6, which is equal to 0. So what does this mean? This means that A of c is equal to 0 on the interval, and I'm going to do the interval 6 to 12, or how else could you write this? Where c is greater than or equal to, and I actually would probably do greater than and 12, okay? Because those were our time values. And A of c equals 0 on the time interval. And you could say because, and then I would probably put this here so that they can see that you did indeed find the slope, and then what's your meaning by what? Mean value theorem. And unfortunately, what would they accept as the bare minimum? The func A of, or V of t is continuous. Bare minimum, all right? But I would hope that I've taught you better than that. Do you see how we identified? Now, was this a problem that had 2 theorems? Yes. What were the clues on the theorems? 2 clues. Guaranteed and closed interval. All right. Do you understand a question exploration routine?